Okay, reflections. These are not as bad. It says graph the function f of x equals the opposite of x squared. Now we know x squared looks something like this. Okay. The opposite of x squared, instead of the point 1, 1, we change that to the opposite, it becomes the opposite of negative, the opposite of 1. So it's right here. Same thing at 2 becoming 4. If we make that negative x squared, now that's negative 4. And what we end up with is something like this. So tagging on a negative sign to the function, that gives us a what kind of reflection? For reflection around the x-axis. Okay. So that's not too bad. We're just taking the opposite there of those function values. Now what if we put a negative sign inside the function? So here, for this square root, of course our original function, if you remember, the square root function looks something like this. We got 0, 0, 1, 1, 4, 2, and 9, 3. So here's our original function. Make a table so we can see it. We're taking the square root. Now what happens if we change that to the opposite and then square it? Well, all of a sudden these points, okay, 0, 0 is still there. If I do a 1 here, that becomes a square root of negative 1, which is undefined. 4 here becomes the square root of negative 4. That's also undefined. Remember, we can't do a square root of a negative, so 9 here would make that square root of negative 9, which is also undefined. So we kind of run into a problem. We don't have those x values there. We do have a point at 0, 0, though. We got that. So what do we need to do for this x value? Instead of plugging in a positive 1, maybe we plug in a negative 1. So then we can take the opposite and get a positive 1. And now I've got a point at negative 1, 1. How about negative 4, 2, and negative 9, 3? Because again, negative 4 here would make that a positive 4. Take the square root, you get 2. And so there's my new graph. What happened? It was a reflection at the y-axis. See that reflection there? So put a negative sign in there with the x inside that function. We get a reflection about the y-axis. And that's basically what this says. Negative sign outside the entire function gets you an x-axis reflection. Negative sign inside the function gets you a y-axis reflection. And here's a summary of all those, and this is also in your textbook. If you've got the hard copy of the book, that's on page 251. You can also find that in the digital copy as well. It's at the end of section 3.5. So that summarizes all those different things we just looked at. Okay, so here's a good question. This is kind of the classic question from this section here. Find the function that's finally graphed after the following 3 transformations are applied to the graph of the absolute value of x. So we want to find out what our new function is after we do this transformation. First we want to shift it left 2 units. So we're starting with this guy right here. After step 1, if we shift it left 2 units, that's a plus 2 inside with that x. The next step, we need to shift it up 3 units. So we're going to take that same thing we had. If I want to go up 3 units with it, I need to tag on a plus 3 to the end. And then if I want to reflect it about the y-axis, I need to make it the opposite of all that. Or I could say that's just like so. And that was actually a mistake. Let me back up. I did a x-axis reflection. And the last piece, and step 3, reflect about the y-axis. That means my x just becomes a negative x. And that's it. And you can actually graph these if you want to do so. Clear this out. So first I need the absolute value of x. And to get that absolute value, that's under your math menu. You hit math, and then hit to the right one, and there's that first one, ABS, is absolute value. That was a negative x plus 2 plus 3. And that's what my final graph looks like. So there it is. We went to the left 2, we went up 3, and then we reflected about the y-axis. So that's why it actually ended up over here, because it was left 2, up 3, but then it got reflected over. Okay, graph the function f of x equals 3 over x minus 2 plus 1, and then find the domain and range of that function. So let's think about what happened to give us this function right here, 3 over x minus 2 plus 1. How, what took place to create that function? First, you got to figure out what function you started with from that library of functions, and that would be, notice that x is in that denominator. There's only one function where we have an x in the denominator. That's that reciprocal function. So that's our basic function. And then what did we do to it? Okay. Well, we did a plus 1 here. Isn't that a vertical shift? Up. Okay. And we also did a minus 2 Isn't that a horizontal shift to the right? And that's 2 units, and we went up 1. And then the third thing we did, this 3 right here, we multiplied that function by 3. So if you multiply a function by a value, isn't that a either a stretch or compression vertically? And in this case, that would be, since 3 is larger than 1, that's a vertical stretch. So we took our original graph, went a vertical shift up, a horizontal shift right, and a vertical stretch as well. And so how do we translate that into the actual graph? Okay. Well, our original function, 1 over x, it actually looks like this. It's this weird sort of shape like this. And really a table is pretty helpful. First, let's do that vertical stretch first. If we have x, 1 over x, and then if we do 3 over x, let's do that vertical stretch part first. Let's just throw some values out here. 1/2, 0, -1/2, and 1. If we do 1 over x, that's 2. Actually, 0 is not going to work here. That would be undefined, so let's just scratch that. -1/2 would be -2, and then 1. If we do 3, multiplying that by 3, we get a 6, -6, and a 3. So, so we end up with 1/2 6. Let me do that in a different color. -1/2, -6, 1 3. And if we do a 2, that's 3/2. And so we get, these points right here. A -2 would be -3/2. Be right here. And I've mislabeled this point here. Okay. And then we need to shift that to the right 2 and up 1. So let's do that in this color. And then here to the right 2 and up 1. To the right 2 and up 1. And so I know this is kind of hard to see. It's important to also kind of understand there's this vertical line right here that kind of splits the graph in two. That also is going to get shifted to the right 2. So that new vertical line is right here. And so what we end up with, if you'll kind of go with me here, something that looks sort of like this. And that, it's kind of a big mess, but the point is, it's, identify what those stretches and shifts are. When you're graphing these by hand, it gets a little tricky trying to get the exact points where they need to be, but you can see kind of the result. We did shift to the right 2 and up 1. The vertical stretch may be a little tricky to tell because my graph is kind of terrible, but on the computer, when you do this on the homework, it's pretty easy to get those in there. You actually just input those values and it kind of draws the graph for you. So the biggest thing is kind of understanding this part of it. If you can kind of see how to get that part, the rest of it's not too bad. Okay, we didn't find the domain and range here. So let's go back. The domain and range kind of goes back to, there's these two vertical lines. I'm sorry, there's a vertical line and a horizontal line that this graph doesn't cross or touch. And it's related to, on my original graph, those two purple lines. The graph kind of doesn't touch those two purple lines. When I shifted that graph to the right 2 and up 1, I got those two black lines where the graph doesn't cross or touch. Those are really important, and they really determine our domain and range. And so what we end up with for the domain, think of the x values there on that graph. It's everything except for this x value at 2. write it just like that. And then the range, what y value is not included. Okay, this horizontal line here at the y value 1 is not included. So that's our domain and range there for that graph. Everything except for the x value 2 and the y value 1. Okay. Next graph here. We've got f of x equals 1 minus x under the square root plus 2. So again, we got to figure out what basic graph we started with, and hopefully you can see that square root in there tells you started with the square root of x. So how do we end up with all of this, all these changes, and what did they do? Okay, well, look under that square root, we have a 1 minus x. If you go back and look at your notes on the different stretches and compressions and things, you don't ever see a 1 minus or a 2 minus x. It's always x plus or minus something. So actually what we need to do first, we can actually rewrite that as the opposite of x minus 1 plus 2. And so just do a little manipulation there. And from that now we can see, all right, this is a vertical, let me phrase it this way, we went up, shifted up 2. This minus 1, x minus 1 was we went to the right 1 unit. And then this negative sign under the square root, that's a reflection. Is that about the x-axis or the y-axis? And the answer is that's a reflection about the y-axis. Since that's inside that function there, it's a reflection about the y-axis. So if we take our square root function, shift it to the right 1 and up 2, and then reflect it about the y-axis, we should have our new graph. So let's see if we can accomplish that any better than what we did on that last one. Here's our square root function, and I'm just going to leave those as points, and well, I guess I could draw a line. So what I need to do first is go to the right 1 and up 2. Okay, so there's my right 1 up 2. And now I need to reflect that about the y-axis. And so I end up with 0, 0 goes to the right 1 up 2, so it's right here. This guy gets shifted over to here. That goes to there. Whoops, actually, didn't go far enough. Need to go all the way to -5. And then this guy's at 10, 5, so it needs to go to -10, 5. All the way across. And so now we get, nope, that's not it. Because that point's not part of the graph. Just this piece right here. Okay, so there it is. Domain and range. For the domain, doesn't this graph dead end here at -1? So it goes from -infinity and then dead ends at -1, but including that point. So we put the square bracket. The range is from 2 on up, right? Including 2. So there's our range. Okay, so that's the end of the section. Hopefully you'll find the homework's not too bad for this one. Maybe a couple tricky questions when you get into some of those compressions and stretches, but otherwise, if you have any questions, let me know.